So now you know how to solve, you know how to graph. Today we're going to talk about set builder notation, which is a little redundant in the whole grand scheme of things, but you really need to know how to be able to read it because it's in every single book there is out there. It is common in math terminology. So when you see something like this, it is read the set of all numbers. That's what these little things mean. The set of all numbers x, and then that bar means such that x is less than or equal to 3. In other words, we're going to talk about all the numbers that are less than or equal to 3. Now, if we were just solving these problems, we could write just that x is less than or equal to 3. But when they ask you technically to write it as a solution set, they mean you need to stick it in set builder notation. Now, we haven't been doing that because they hadn't taught you set builder notation yet, but now they have. So when they want that, they will specifically say put it in set builder notation. If they don't say that, you can just leave it like we have been leaving it. But if they do say it needs to be in set builder notation, make sure you write it with the fancy little braces and everything. Now I know you're saying to yourself, I can't draw them braces. Sure you can. Don't take forever to do it. Squigglies make me happy. I promise you, I've learned to live with a lot less. As long as you know what it is, and it looks something like that, you're fine. Doesn't have to be perfect, doesn't have to be great. I know how you can get. Just make sure it looks something like that. A little bit of squiggle there to let you know that it's not absolute value, or to let you know that it's not a parentheses, that it's something different. It's not brackets. It's a brace. So a little bit of a squiggly line, and we're kind of good. So for this one, they want us to solve and graph and then write it in set builder notation. So the first thing I have to do is solve it. So I'm going to draw my line. I need to get all the letters on this side. They are. Get all the numbers on that side. So I'm going to subtract 24 from both sides. Gives me negative 4x is greater than negative 28. Divide both sides by negative 4. That negative makes my sign change. So that'll end up giving me an x is less than positive 7. So I got my 0 and my 7. Open circle because it's not included. And put it going this way. So far, so good, just like we've done for the past few sections. Now we have to write it in set builder notation too. So I go and I draw my little squiggly. I write x, because that's the letter we got, such that, and then I write this whole thing down. X is less than 7. And put my last little squiggly. That's it. Take a few seconds, try the second one, and let's see how you do. Okay, so I'm assuming you took those few seconds. You tried the second one, and we'll see how you did. So the first thing I'm going to do is draw the line. Have to take care of my parentheses. My negative 10 and my positive 10 will cancel each other out. Divide both sides by 2. Get x is less than negative 4. Got a negative 4 over here, 0 over there. Gets an open circle because it's not included. Then we go to the right. Sorry, to the left. I drew it the right way. Then we got squiggly x such that x is less than negative 4. Ta-da! All the hard stuff done. Well, not quite. There is something else we need to go over in this section. Took care of all the notation stuff. Now we got a much bigger problem. Let's look at a problem like 2 times 14 minus W minus 11 is greater than or equal to 17 minus 2W. They want the same kind of thing. Solve it, graph it, and write it in set builder notation. So I draw my little line. Go through the problem the exact same way. Got parentheses, so I'm going to have to get rid of it. That's going to give me 28 minus 2W minus 11. 17 minus 2W. 28 minus 11 is 17. Now I've got to get my letters on this side, so I add 2W to both sides, and I add 2W over here. And I get 17 and 17. Problem. Can't graph anything if there's no letter left. We have no letter left. Is this a true statement or a false statement? Because that's what we did when we were doing equations and we came up with something like this and all of our letters went away. The question we asked was, is this true or not? Is 17 greater than or equal to 17? Why, yes, it is. Yes, this is a true statement. That's still not my answer. Since it is a true statement, that means my answer is all real numbers, just like it was before, but I still have to graph it. So Ellen real. How do we graph all real numbers? Well, it's every number. So it gets everything on the line. Technically, following Miss Rogers' rules, there needs to be a 0 in there somewhere. But it's everything. And we have to write it in set builder notation. X such that X is a real number. Well, that was interesting. Okay, if that's the case, then, what happens if it's the other way? Because before it could be true or it could be false. What happens if we have one like this? Still might be really to go. 5x plus 3x plus 12, and then 40 plus 8x gives me 8x plus 12, and 40 plus 8x. Subtract my 8x from both sides. Just like we anticipated, we end up with 12 greater than 40. True or false? Well, this one's false, which means our answer used to be no solution. Answer still is no solution. Remember I said nothing else changed except dividing by a negative. So how do I graph that? Well, there's nothing to graph because nothing works. So we don't graph anything. And then, notice, darkened in everything, darkened in nothing. You got to make that distinction. Then, for my set notation, no solution. Nothing works. So you know how to graph them. You know how to write them in set notation. You know what that means now, right? Classwork, homework time. Page 100. Sorry, page 200. I'm moving through this book. Classwork, practice exercises. Numbers 12 through 18 even. And 24, 28, and 32. Homework. Practice exercises. Numbers 11 through 17 odd. And 25, 27, 29, 33, and 37. Okay. Catch you later.